Right, hello. I'm going to give a presentation all about my proposal for improving and revitalising the Open Wonderland platform. This is based on a presentation that I already gave within Open Wonderland itself on a Wonderland Wednesday. As promised to the members there, I said I was going to record the presentation and put it online for the benefit of those who weren't able to attend. So here it is. I myself am Carl Jokl. I am the founder of a company called Jokl Technologies Limited, a company with which I'm hoping to use to help develop new mobile clients for the Open Wonderland platform and to ultimately improve and revitalise the platform. So, to start off with, a bit of background. Open Wonderland originally started off as Project Wonderland at Sun Microsystems. This is a project that came to be because there was a problem within Sun Microsystems that at any given time more than half of the employees were working off-site. That caused problems with collaboration between employees. Around the same time, the Second Life platform was growing in popularity, and lots of companies and organisations were interested in pursuing creating virtual environments for both collaboration and education to see what this new technology might be able to bring to the table in terms of distance learning and remote collaboration. Now, Second Life had a number of limitations. Firstly, it was controlled completely by Linden Labs, hosted on their servers beyond the control of corporate entities who may have had security issues with having data or services that run beyond their control. Also, being controlled by Linden Labs, the level of customizability was constrained to the level that they permitted. So many people started out during this time with Second Life as a platform, and many people still use it today, but due to the constraints it was considered as an alternative whether a new environment or platform could be created similar to Second Life, but which could be hosted within a company and which could afford high levels of customizability. And thus the Wonderland platform came to be. Wonderland was under the umbrella of the project Looking Glass at Sun Microsystems. So Looking Glass would breathe the connection with the name, with Alice through the Looking Glass. So this developed into Sun Microsystems. It was originally based on Java 3D technology and the Darkstar gaming server and the JVoice bridge, all technologies that had been developed as projects under Sun Microsystems. So as well as providing a collaborative environment, it also provided a showcase for a lot of Sun Microsystems technologies. The project gained a lot of popularity up to version 4 under Sun Microsystems. Then a big push came for version 0.5, which was a big rewrite and involved an awful lot of changes. During this period, Sun Microsystems was acquired by Oracle. Oracle, having taken over all the Sun Microsystems projects, decided that they didn't want to continue development of Project Wonderland. At this point, some of the team that originally developed Project Wonderland split off and formed their own foundation, the Open Wonderland Foundation, and Open Wonderland became the open fork of the Project Wonderland project that had been developed under Sun. The Open Wonderland Foundation still exists and exists to keep the project alive and continue development. It acts as a non-profit organisation which people can donate money to continue development of this project. Now, the Open Wonderland platform hit the 0.5 milestone some time ago, and currently the client is only available for the desktop. There are no mobile clients, or no officially supported mobile clients for Wonderland. There are also some limitations and stability issues, as you might expect with any 0. whatever release. It's not a 1.0 and beyond release that's full feature complete and fully stable. It's still considered in the beta stages. So now there's the question of where do we go from here and what happens next. So now we look at some of the original considerations that were around at the time that Open Wonderland was originally put together. I would think this is probably around about 2007-2008 era, roughly. So Wonderland acted, as mentioned, as a showcase for lots of Sun Microsystems technology. The stack was Java from top to bottom. All the components, both on the server and the client side, were all developed in Java and using products or projects that were developed by Sun Microsystems. Java, Java 3D, the JVoice Bridge, Darkstar, delivered from Java WebStart, and so on. There was a desire or a justification for the development of Wonderland that if Wonderland was successful, and particularly the likes of Project Darkstar was successful, this would be an opportunity to drive server sales, Sun being a server company. If they could sell servers to companies to run Wonderland instances, then that was a revenue path that would allow them to monetize in Wonderland. Mobile devices were not properly supported right from the outset, but the technology of that era was much more limited. Smartphones were nowhere near as powerful as they are now. They didn't have the same capabilities. Back then, Java 3D, Java ME, Java Micro Edition, was still quite a big player in the space, but didn't have the capabilities necessary to power something as complicated as a 3D virtual collaboration environment on a phone. And as mentioned, the initial focus, or the initial reason for creating Wonderland, was for business collaboration. Circumstances have changed. In the intervening time between 2007 to now, which is 2014, there's been a big move away from desktops to mobiles and tablets as the primary device that many consumers use today. Also, along with that, these devices have become increasingly more powerful and have much greater graphical capabilities. Gaming graphics and technology is continuously improving. Java is reducing in popularity as a client-side technology. There have been a number of security scares related to Java and the Java plugin in the browser in particular, which has made technologies such as Java applets and Java WebStart difficult to work with because it's no longer as sure that a given client will have Java installed or Java running in such a way that it's accessible via the browser. Also, Java Micro Edition, the mobile version of Java, has also dwindled in popularity. Now, I'm not an anti-Java individual. I'm actually a member of the London Java community, so I have a vested interest in promoting Java and in progressing Java technology. But I'm also pragmatic that Java does have certain problems. Java and platforms similar to Java all suffer from a similar problem that if you're trying to create something that runs across platform, you're generally limited to the lowest common denominator of what will run across all those platforms. Java is still very popular as a server-side development technology. As mentioned, as a client-side technology, it's dwindled very much in popularity. It's still been demonstrated that very impressive things can be done with Java, particularly Java gaming technology. I have examples of this, that one of the most popular games of all time, Minecraft, uses Java technology, which has been customized with some extra libraries, but essentially it's a Java-based game and highly successful. Another example of a Java-based game that's been quite successful and a very good showcase of rich 3D graphics and gaming capabilities, a game called Spiral Knights, which is probably less well known, but it's one of these games that would probably be a backhanded compliment that you wouldn't know it was a Java game to look at it. It just looks like any other native game application. Technologies with 3D engines for Java, such as the JMonkey engine. The JMonkey engine is actually currently what is being used as the main 3D engine for the 0.5 version of the Open Wonderland platform. And people have managed to do some interesting things with it, and it's proved itself that it can be used as a capable engine. The problem that we have with the use of Java technology and Java engines is that it's another layer of abstraction over the native graphics capabilities. By using a third-party engine that isn't highly integrated with the native platform, if problems occur with changing graphics APIs or drivers or issues or whatever, they have the problem of trying to manage the 3D engine that's developed separately from Open Wonderland and having to keep upgrading versions or dealing with problems with that separate to the development of the Open Wonderland platform itself. Another factor is that the mainstream game industry and practically all the AAA titles in existence today are developed in C and C++. That's the dominant programming language for the gaming industry. And now we have the situation that Java cannot be assumed to be available across all mobile devices. In fact, there are certain platforms such as iOS where, out of the box, without jailbreaking the device, Java is simply not available. And it's unlikely that that's going to change for the foreseeable future. So, with that in mind, I propose a different strategy. What I propose, using the fact that there is a drive to get into mobile clients, to take advantage of this opportunity to develop some new native applications and native clients for Open Wonderland. My proposal is to try and use the highest performing graphics library or graphics API on a given platform. So for example, on macOS that may be OpenGL. On the iOS platform it's just been announced that there's a new API Metal which is very highly tuned to the graphics capabilities and graphics hardware on modern iOS devices. On the Windows platform and Xbox platform you have versions of DirectX and similar or other highly tuned APIs on other games consoles. The advantage of trying to use these technologies is to aim to have the highest performing graphical experience on any given platform, and also to try and have a very seamless platform integration. It's hoped that by doing this, each individual Open Wonderland client will work seamlessly with the underlying platform and feel like it's an application that belongs to that platform rather than something that's been shoehorned into it to be easily cross-platform but hasn't been designed with a specific platform in mind. Hopefully this should maximise the rendering and general performance of the client and also allow for very fast startup times. Now, I've made a rather ambitious target in terms of supported client platforms for Open Wonderland. On the desktop, we'd hope to support Windows, macOS and Linux. On the mobile side, we'd hope to support Android, iOS and Windows Mobile. And on the console side, hope to support the Xbox platform, PlayStation platform, Nintendo platform. Now these are just targets. I'm aiming high. There's no promises or guarantees that all these targets or these platforms will be reached, but I'm hopeful that, or at least I like to aim for, trying and attempting to have clients available for all these platforms. And covering all these platforms, I feel quite comfortable that should cover the lion's share of any of the users who might want to use Open Wonderland. So that any other platforms, it's reasonable not to support for the basis that's saying that the other platforms would be too small to justify supporting them, unless of course with Open Wonderland being open source someone is free to port to another platform if they would like to. Now there are certain problems with trying to do this. One of the reasons that Open Wonderland uses Java in the first place, or the advantages of using Java, is that Open Wonderland is completely customizable, and all these customizations are written in Java, and as such, any customization written can automatically be deployed from one platform to another, taking advantage of Java's cross-platform portability. If we develop native applications, there's a problem that we can't just automatically be able to customize the platform in a way that is cross-platform, will work across both desktop and mobile and different operating systems. So we still end up with a problem that Java had solved, and we have to approach the problem differently. So how can we deal with different operating systems in this scenario, and how do we deal with interoperability between desktop clients for Wonderland and mobile clients? My suggestion as regards customizability is that most game engines in existence have some form of scripting engine. My proposal is to use some form of virtual machine. This could be based on the Java virtual machine or low-level virtual machine, and that just the portions of Wonderland that are customizations will be deployed to those clients in bytecode form to be executed within the scripting engine. It's possible on certain platforms that some form of just-in-time compilation could boost the performance of this code, but in practicality, mobile operating systems that aren't jailbroken or otherwise rooted are typically not trusting enough of third-party code to allow them to have access to a just-in-time compiler. So it may be something that could be investigated, but in likelihood in practice it probably wouldn't be permitted for security reasons, but certainly as a from a purely technological standpoint it's theoretically possible. So again, looking at the customization architecture, the idea would be that customization on the server would carry on as it always has, in the form of Java modules and Java code. These would be supplemented with some form of bytecode generation, so that client code could be written in some form of language that's able to be compiled down to bytecode, and bytecode will be generated and sent out to the client. It's possible with this that it may be an avenue to go down, that we don't stick to simply just one sort of form of bytecode, but potentially could support several different bytecode formats for different clients based on what the end target platform is best optimized for. So this could be Java bytecode for the JVM, low-level virtual machine bytecode, or intermediate language for the CLR. In each case, this bytecode will be fed into the scripting engine virtual machine, and then the native client will be responsible for having an implementation of all the APIs that could execute the script code. So speaking of APIs, Open Wonderland has an extra module that was developed to try and make customization simpler, inspired from things like Linden scripting language, which had a much simplified API aimed at more casual developers for their 3D environments, so that the barrier to entry was less. Now, this module that was created to handle that was EasyScript. If we develop some kind of cross-platform APIs, cross-desktop and mobile platform, it's likely that the functionality in EasyScript could be a good basis for creating a general set of APIs that every Open Wonderland client should support as standard. This would be very much focused on high-level functionality, things like moving an object or model around in the 3D world, performing certain types of very basic operation, basic animation, basic customization. We have another problem of cross-platform user interfaces. Now my suggestion to try and tackle the user interface problem is to look at JavaFX technology. Originally, when JavaFX was developed, it was envisaged as a cross-platform technology, not just cross-desktop platform, but a technology designed specifically from the outset to go from desktop to mobile to television to set-top boxes and so on. So all the APIs and the architecture was structured in such a way to try and make it agnostic of whether it's running in a desktop operated with a mouse versus running on a mobile device operated by touch, or a television operated with a remote control, or a games console operated with a game controller, or so on. Because it was designed with this same cross-platform capability that we hope to achieve with Open Wonderland, it would make a good candidate for basing the user interface APIs on. It looks from my investigation as though attempts have been made, or implementations have been made, third-party versions of JavaFX on given platforms outside of Oracle's reference implementation. That being the case, it should theoretically be possible to expose the JavaFX APIs from a native client with a native implementation that is highly integrated with the 3D engine. Also, the JavaFX APIs were designed to have some basic 3D capabilities, which would be another way of potentially be able to do some basic customized 3D rendering or 3D interactions above and beyond anything that's been coded ahead of time in the core client. So looking beyond just mobile clients, mobile provides an interesting opportunity because there are no existing clients, meaning that anything that's developed now doesn't have any kind of legacy support to be concerned with. We don't have to worry about mobile backwards compatibility because nothing exists presently. This means it can be a completely clean slate implementation, and also has some possibility that if a particular implementation or a particular approach is attempted but fails, it can be discarded and another approach can be made. But having developed a mobile client for Open Wonderland, it would be desirable to try and take the same high performance native client and port it across to the desktop. Given that mobile clients are typically a lot less powerful than desktop computers, this should keep the minimum requirements to run Open Wonderland relatively low, because if we're designing it from the outset to make sure that the minimum requirement is to run on a mobile device, then the desktop version of Open Wonderland could have those capabilities and be beefed up to support the full range of capabilities of the graphics hardware on the desktop. Along with this, it would be desirable as well to have native installers, so a Windows installer or a Mac OS installer or so on Linux, some kind of packaging system like a Debian package or an RPM or so on, for slick interaction with the underlying operating system. Now that covers the native clients, but there are certain situations where you may not wish to have to install an Open Wonderland client, particularly certain types of clients may be very security sensitive about permitting any kind of software being installed on their computers. In that case, I propose having a WebGL based implementation that can simply run inside the browser without any kind of software needing to be installed. This would likely have to be cut down and not have the full capabilities of the native client, but at least it would have the nice compromise of having something available that doesn't require any installation or plugins to work. Now, workload here, in this instance, we're not talking about software workload. This is a matter of carrying out the work of implementing the client application. Now, developing a 3D engine is a serious undertaking, requiring a great number of specialist skills. There are only a limited number of people who have skills in the development of 3D engines because it's very specialised, and those people tend to be in high demand for the same reason. Jokl Technologies Limited, the company that I founded, aims to have the tools, the licensing and the agreements with all the relevant companies and distributors to be able to develop for the 9 target platforms. So looking at all the software licenses and the tooling needed to be able to develop for Windows or Mac or Linux or the games consoles or the mobile devices and so on. This isn't intended to mean that Jokl Technologies alone is the only organisation, and the people who are involved with it are the only people who can develop for it. It does mean that because the company exists with those agreements and the tooling available, there is a company entity that's equipped to carry out development and could potentially bring other people in and make use of the existing resources to carry on development. It's my hope that if I'm able to spark enough interest, I can engage with the London developer community, maybe have certain hacking sessions or put on events where people can take a look at getting involved in the Open Wonderland project and join the development effort. When it comes to publishing, then the fact that the agreements and licensing already exist, then the work that's been contributed can then be published under the Jokl Technology corporate entity. Now, we need a starting point. So what are the first steps? My focus will be to aim for supporting Android and iOS first, because between these 2 platforms they cover the lion's share of the mobile space. Now, Android has recently overtaken iOS in terms of market share, but iOS is still significant enough in terms of its coverage that both these platforms are highly relevant. It tends to be that Android is increasing in popularity and dominance on the phone side, but iOS still remains dominant along with the iPad as the dominant tablet platform. My aim is to try and get a proof of concept working as soon as possible to establish that the technique and the approach chosen will actually work. My focus is to try and limit the scope as much as possible, aiming to do a very small set of functionality, but do that functionality very well, and once that core functionality is established, expand out and add the capabilities bit by bit until the full capabilities of the existing desktop platform are supported. So looking at a very, very bare bones native mobile app, the absolute first starting point is to actually be able to communicate with the Open Wonderland server. This may involve a client that doesn't actually have any UI at all, but simply stubs that out, makes the communication calls, authenticates with Wonderland, gets all the shared server state, and then maybe just dumps that out to the console. And then a very simplified UI, maybe just with wireframes or points or whatever, just to demonstrate that very basic rendering can be achieved, and then expand from there into increasingly more detailed 3D rendering. So this will be the first starting point from which to proceed. There are other options that could be used for stopgap solutions to try and develop something quickly. There are already existing cross-mobile platform technologies that involve 3D engines, such as the Marmalade platform. Marmalade actually has a presence in London, and I have been to their offices a couple of times for C++ meetup events. There's also the possibility of using Unity, which is a cross-platform gaming engine. Unity would have to be licensed as much as any other games engine would need to be licensed. It would mean that a new engine would not have to be developed from scratch. There are downsides to using a pre-existing 3D engine, because traditional 3D engines are designed for traditional games. Now, the likes of Open Wonderland and Second Life are not traditional games, and the performance characteristics are different because a traditional game is optimized for the vast majority of the environment being static and not changing. Typically you'll have a map that's loaded ahead of time, be a certain subset of objects and items and parts of the scenery that can be interacted with and changed, but the bulk of everything else doesn't change. Now, in both the cases of Second Life and Wonderland and any other similar 3D collaboration environment, the engine has to cope with the capability that anything in the whole virtual space could change at any time. That creates much different constraints and makes it different and difficult to optimize for the same ways a traditional engine can be optimized for a traditional game. This is still very much an area under research. It's not a solved problem, which is why the engines and the platforms and clients for the likes of Second Life and Wonderland look quite primitive compared to more traditional 3D engines, because it's just a much newer way of collaborating that hasn't had the same level of experience as traditional games have. But because it's also new, that creates a new opportunity to break new ground that hasn't been covered before, and to allow for possibilities of functionality that hasn't been achieved before. There's also one other solution potentially whereby there are services available now that will allow for graphics to be rendered on a remote server and simply a viewport to that rendered image to be streamed across the internet. So a mobile device will see 3D rendered image, but that rendering doesn't take place on the device itself, it's happening on servers out in the cloud, and just the image is being streamed across to the client across a network. And that would also provide another potential stopgap solution that could reuse some of the desktop code. But ultimately, in the long run, my proposal is to develop a new native mobile client. Now, along with the technical aspects, there are also some philosophical aspects to what I would like to achieve with Open Wonderland. Open Wonderland, as it exists, is a completely open source platform from top to bottom. It's licensed and GPL'd as far as I'm aware. I would hope that any solution that supersedes it, including the mobile solutions, carries on with this tradition of having a open source implementation, even if that's a reference implementation and other third-party companies might develop high-performing proprietary solutions that are paid for. The fact that other companies are willing to do that isn't necessarily a bad thing, because the fact that they want to do that demonstrates that they see value in the Open Wonderland platform sufficient to develop their own clients. And the more people who use the platform, the more it increases the value of the platform, which is good for everyone. But I would always wish for there to be, at any given time, a fully open source solution that's available to anyone free of charge. My hope from a business perspective is that certain entities such as universities and businesses that have financial resources available will be able to pay for their own commercial customization or academic customization, and the revenue generated from this would allow, in general, investment in the platform to improve it, so that other organisations that don't have those financial resources can just take the platform for free and use it as is and customize it themselves as they see fit. This keeps it in a state that the clients who require the commercial support and money isn't a limitation have that option, but the people who are financially constrained can always get the platform for free, and it remains free and open source for those people. In terms of mobile capabilities, my hope is to try and support a very lightweight mobile client based on very limited devices. My hope is to try and see if I can get a mobile client that works on something as limited as a Raspberry Pi. Now, the Raspberry Pi has 3D graphics capabilities, but it's very constrained in terms of processing power and memory, so it will definitely be a challenge to try and support a device of that limited capability. But the Open Wonderland platform was always designed from the outset that it doesn't mandate a specific client implementation. It was always theoretically possible that a client could be created that isn't even 3D, it could be a 2D representation. The server will synchronize the state to the client, but it's up to the client to decide how to render that. It doesn't have to be a 3D perspective, or it doesn't have to be a massively detailed 3D perspective. The client can then decide the level of detail to use to render it. So my hope is to try and have it run on something as limited as a Raspberry Pi or something, a small portable device like Google Glass. ARM devices such as these, which are ARM being the most popular processor platform available for mobiles today, many of these processors have the Jokl Java bytecode acceleration. Having spoken previously about embedding a scripting engine within Wonderland, it might be possible if a Java virtual machine is used as the choice of scripting engine or the bytecode engine, to try and accelerate that using Jokl. Along with these capabilities, my hope is to expand out the support for different types of modelling formats. At the moment, OpenCollider is being used because it's an open source non-proprietary format that's readily available. It's the same format that's used in Google Earth, but at the moment, with that being the only supported modelling format, my hope will be to try and expand that to other formats that are easier to use with 3D artists, such as Maya or 3D Studio Max modelling formats and mesh formats that can be more seamlessly exported from 3D graphical artists and added into a Wonderland environment. My hope is also to try and look at supporting a very common set of functionality across all platforms. Now, the Open Wonderland platform has been designed from the outset to be completely modular. Everything that Open Wonderland does and every capability it has is implemented in the form of a module. Modules can be added or removed dynamically, so there isn't a mandated set of capabilities that Wonderland is to have. Everything is defined as a module. But my hope for as a more pragmatic solution looking forward is to try and mandate a certain minimum set of functionality such that these can actually be implemented as part of the native client application, so that it isn't reliant on third-party customization. Good candidates for this kind of capability would be all the voice bridge capability, PDF rendering and display, which is tied into doing presentations within Open Wonderland. There's also a 3D browser or a browser window that can be planted in a 3D world to be able to open websites. There's sort of application sharing capabilities using, I believe it can use Xserve sharing, but may be able to be expanded to use things like VNC or other kinds of remote window sharing technologies, and have that also be embedded in the core platform and use native code for maximum performance. Looking at the JVoice bridge, this is currently implemented as a pure Java solution and is deployed in Wonderland as part of a module that runs on an application server. Now, this doesn't, from my perspective, make perfect sense to do that. Having looked at the JVoice bridge code, it doesn't look like it's been actively developed for about 5 years or so now, so it's in a reasonable stable state. And my proposal would be to try and port it to native code that can be run rather than running inside the application server, have it run as a native background service. So on Windows it would be a Windows service, or Linux or Unix it would be some kind of Unix service that just sits and runs in the background, providing that voice speech capability. Having it be a native implementation has other advantages on certain platforms, because many platforms today offer both the capability of using speech synthesis and speech recognition. And my hope to try and implement or provide hooks or functionality available to the voice bridge that could allow audio streams from people speaking to be fed into speech recognition, so they could be transcribed for people who either don't have any audio capabilities or may be in some way hearing impaired, so that they're not excluded from the interaction. And going in reverse, this could allow for any kind of text within the virtual word to be converted to audio by speech synthesis and then outputted through the voice bridge. Working with a native application, it's my hope also to look for ways of seeing if we can compress the audio streams to increase performance and reduce the network load from the current implementation. Also look at potential ways to try and make whatever approach is used more firewall friendly, as there's sometimes been issues with trying to connect to the voice bridge when servers are running in different configurations with firewalls in between. So to summarise what's been covered, Open Wonderland requires mobile clients. It doesn't at present have any mobile clients, and it's important moving forward that it has mobile clients in order to remain relevant. It's proposed that we replace the existing Java clients with a combination of native clients and a WebGL implementation. It's hoped in the short term to create some kind of rapid prototype as a proof of concept. This may make use of certain temporary solutions to get something up and running quickly, but the long-term solution is to try and develop a new native 3D engine specifically optimized to work with Open Wonderland. As part of that new 3D engine, we hope to embed some kind of virtual machine technology to allow for customization, and that customization will also involve cross-platform APIs for the UI, hopefully based on Java effects. Aim to have very low minimum requirements, as low as hopefully being able to run on something as simple as a Raspberry Pi, and also look to try and adapt or port the existing JVoiceBridge implementation to a native background service that can run on natively on server platforms. Now this would be the questions section, except I'm talking to the internet that cannot talk back to me directly. So if you have questions, I will provide contact details that you can get in touch with me, and I'll try and get back to you, but I tend to be quite busy, but I will do my best to respond to any queries.